In this video, we're going to solve some chemistry practice problems together. My hope is to show you that you don't need to memorize a lot of things to be able to solve these practice problems. Rather, you can solve most of these by relying on understanding a few fundamentals in organic chemistry. Also, these problems do not cover the same topic, and this was done on purpose to make it similar to what you might encounter in an exam or a test. I highly suggest that you pause the video and go over these problems on your own, and then you can play to see whether or not you got it right or wrong, or which steps you got it wrong. Alright, so let's start with the first one. It says draw the reaction mechanism for the following reactions, and in these type of questions where you're given the product, it's a little bit easier because at least you know what you're aiming for. Okay, so always in reaction mechanism, the first step you need to do is to identify a nucleophile and the electrophile. So maybe just take a few seconds and see if you can identify a nucleophile and the electrophile. So we have hydrogen bromide right here, and I know that bromide is electron withdrawing, so it's going to pull electrons towards itself, leaving a partial positive charge on hydrogen. And I have a double bond right here. It's very electron rich, so this could be my nucleophile, and this hydrogen is going to be my electrophile. So always start there, and then this ethyl group, there's nothing really special about it, so it's not really a nucleophilic center or an electrophilic center. After identifying the electrophile and the nucleophile, I know in organic chemistry we always start by the nucleophile attacking the electrophile. So let's draw that arrow, and because we're making this bond, something has to be broken, and we're breaking this bond right here. Now, the hydrogen can either attach to this carbon or this carbon. So let's draw the two intermediates. And this could be here, which means we're going to have a positive charge right here, or hydrogen can be right here. Now, which one of these carbocations is more stable? So if I look at it, this is a secondary carbocation, and this is a tertiary carbocation. And I know that tertiary carbocations are more stable than secondary carbocations, because those alkyl groups are going to help stabilize that positive charge. So I'm just gonna put an X through this. So this is going to be our intermediate with this positive charge right here. Now we have bromide ion just floating around in the solution, and this is negatively charged now. And that's why this is a good nucleophile. So the last step is just that this is going to attack this positive charge, which is our electrophile. And this gives us our product. So I just solved this by relying on the fundamentals, which are understanding what nucleophiles and electrophiles are and stability of carbocations. Okay, so let's move on to the second one. Okay, so first of all, let's just take a second and look at the products and the substrate. So if I look closely, I see that this carbon is attached to two alkyl groups, NOH. This carbon is the same, one OH and two alkyl groups. Now if I look at the product, this carbon now has 3 alkyl groups, and this carbon has only 1 alkyl groups. So in total I still have 4 alkyl groups, but one of them now has 3 of them. And this should indicate to you that probably something happened in between, and that's probably an alkyl shift. So let's see if we can identify what happens. We are in an acidic environment and we have an OH group right here. So what do you think would be the very first step that happens? If I put this molecule in the acidic environment, what happens? So remember that oxygen has lone pair of electrons, so this is going to attack this hydrogen and it gets protonated. That would be my very first step. Now we have OH2 positive, and every time you see that, the first thought that you comes to mind should be leaving group, because this can leave as water, and we know that water is a very good leaving group. It's very stable, so that's what's going to happen. This just leaves. We get a carbocation intermediate. Okay, so now this carbon still has two alkyl groups. This has two alkyl groups. So something must have happened. And the most logical thing is that an alkyl shift is going to happen. So one of these alkyl group is just going to attach to this carbocation, and we're going to rearrange that to get another carbocation which is more stable. So now the positive is here. Now we have three alkyl groups, just like our product. 1, 2, 3, and now the positive is right here. So if I compare this intermediate with my product, the only thing that we're actually missing is this double bond or ketone. And because we have this alcohol group and we're in an acidic environment, it means that we'll have the conjugate base or water floating around. So actually I forgot this step. We lost water, so we have water right here. So the conjugate base is now going to grab that hydrogen, and we're going to break that bond to make this double bond or the ketone. And that carbon is no longer going to be positively charged, and this would be our product. So again, just by relying on the fundamentals, you could easily come up with the reaction mechanism. So let's move on to another one. So again, as always, start by identifying nucleophiles or the electrophiles. So HBr, again, has a partial negative, partial positive, and I have a double bond which is electron rich, meaning this is going to be my nucleophile and this is going to be my electrophile. So the very first step in organic chemistry, nucleophile attacking the electrophile, breaking that bond. We make this carbocation here. Now, why did I put the positive here and not on this carbon? So remember, again, this is going to be a secondary carbocation. It's more stable. If I put it right here, it's going to be primary and it's not going to be stable. Okay, so again, if I compare this intermediate with my product, we have 4 carbon here, but now here we only have 3. So something again must have happened, and again this looks like a alkyl shift. So let's just start with numbering carbons. So again, numbering carbons is it's a very good technique to help you keep track of the number of carbons so you don't get lost. So 1, 2, 3, 4, 5. Now what happens is that an alkyl shift is going to happen, or a rearrangement. So this is going to now attack here and form a bond. So we're now going to make this green bond between carbon number 5 and carbon number 2, and we're going to break this bond here between 5 and 3. So let me just draw this here. So if you want to kind of imagine it, it's like this: 1, 2, 3, 4, 5. So now if I count the number of carbons here, it's 1, 2, 3, 4. Voila! So it's exactly the same as my product. Let's draw that. Okay. So where do I put the positive charge? So again, this is where numbering becomes very helpful. So 1, 2, 3, 4, 5. And in our previous intermediate, the positive charge was on carbon number 2. But now, because we made that bond, this is no longer going to be positively charged. It has a bond now. But we broke this bond between carbon number 3 and 5. So the positive charge is now going to be on carbon number 3. And last step, bromide ion around, good nucleophile, we have an electrophile. So a very simple attack is going to give us our final product. Okay, so these were all the questions that I wanted to do in this video. Thank you for watching. If you like these kind of practice problems, please comment below, and I will definitely make more of these.